Hello again. So in this video we'll look at the final piece in this puzzle of Gaussian elimination. So what do I mean by this? So I have already told you how a linear system of equations can be written as a matrix times a vector equals another vector, and this can be written using an augmented matrix. Yeah. So this you have seen. You have also seen how you can have a matrix in row echelon form, which has the pivots and so on, and also how to solve that matrix in row echelon form for all of the variables x. So you have seen this. So the only part that is still missing that we will do in this video is the Gaussian steps, which take you from the augmented form A and B, which are the original linear system of equations, into the row echelon form. Remembering that the solutions for x are the same. Yeah. So ux equals c must have the same solutions as ax equals b. So basically Gaussian steps consists in adding and subtracting equations from each other. So let's formalize it. Allowed Gaussian steps. First one is you can swap any two rows. For example, we are going to choose a notation for this. So for example, you can say the row 3, I want to swap it with the row 5. And you can write it like this. Next, you can multiply a row by a non-zero scalar. And the way we can write it is we start with row, for example, row 4, and we multiply it by scalar k. And the result of this, we place it in the row 4. So that's how we would call it. And finally, the most important step is we can get any row and add to it a scaled version of any other row. And the way one would write this is, for example, you get row 3, and you add to it a scaled version of another row, for example, k times r1. And the result of that operation, you place it back into row 3. And this is how you would write it. So those are the three types of Gaussian steps that we can do. So our aim in this middle section, which is the main the biggest part of Gaussian elimination, is to use these steps wisely in order to reduce the original system into row echelon form. So let's look at an example of how to do it. So in this example, we start with this augmented matrix A and B. So remember, I'm going to write the matrix of coefficients here. These are the coefficients of the variables. Then I write a line, and then I write the independent coefficients here. And this is my augmented matrix, A var B. So now I need to convert this into row echelon form. So what I do is I start from the first row, and I say, okay, does the first row have a pivot? Yes, it has this pivot, the first non-zero number. Yeah. So okay, let's use that number as the pivot for the first row. Now we need the second row to have pivots. Yeah. And the pivots for the second row need to be to the right of the pivots of the first row. As we know, that's one of the properties of the row echelon form. But currently, the second row has this pivot here, which is not to the right. So we don't want that pivot. We want the pivot to be either here or here. It doesn't matter. So what we need to do is that we need to make this number equal to 0. Okay? So therefore, we do a Gaussian step, which is the following. If we get row 2, and we add twice the row 1, and the solution, we place it into row 2, so the result of this Gaussian step is the following. The first row remains unchanged. But the second row, we have to add twice the first row. So minus 2 plus 2, 0. Minus 2 plus 2, 0. Minus 3 plus 4, 1. And 1 plus 2, 3. So that is our second row. Okay. Now we can, in the same graphical step, we can do another step here, acting on the third row. Yeah. So we also want to have a 0 in this 4 here, right? Because whatever the pivot is for the third row, we want it to be to the right of the first pivot in the first row. Therefore, this 4 we want it to be a 0. How can we do that? It's very easy. You get row 3 and you subtract 4 times row 1. And the result, we put it into row 3. Okay? So let's do that. So 4 minus 4 is 0. 6 minus 4 is 2. 8 minus 8 is 0. And 1 minus 4 is minus 3. So this has been our 2 first Gaussian steps. So right now the pivots are this one in the first row. We have this one, which is the first non-zero number in the second row. And in the third row, we have this one. So this is not in row echelon form because the pivots always have to be to the right of the pivots above them. So these 2 pivots are in the wrong order. Yeah. So one thing that is very easy for us to do is to swap those 2 rows, which is another Gaussian step. Okay. So we do this Gaussian step, which is row 2, swap it with row 3. And we end up with the following matrix. Okay, now the pivots. The pivot in the first row is this one, the pivot in the second row is this one, and the pivot in the third row is this one. And now this matrix is in row echelon form, and indeed you can do this staircase here. Okay. So that would be an example of Gaussian steps applied to this matrix. So now we have this augmented matrix in row echelon form, and therefore the next step would be, so we are here. So the next step would be to solve for x, as I showed you earlier. Yeah. So in this case we have 3 pivots. The 3 columns have a pivot, so we are in case 1. There is a unique solution, and we solve it by inverse substitution. So let's do it. So we start from the bottom row, and the bottom row tells us that 1 times x3 equals 3. Therefore, x3 equals 3. Now we go to the second row, and the second row is telling us that 2x2 equals minus 3. Therefore, x2 equals minus 3 halves. And then the first row is telling us that 1x1 plus 1x2, which is equal to minus 3 halves, plus 2x3, which is equal to 2 times 3, which is 6, equals 1. That's the first row, having substituted the solutions that we already got. Therefore, x1 equals 1 plus 3 halves minus 6, which is equal to whatever that is, minus 7 halves. So our solution for x is x1, x2, x3 equals minus 7 halves, minus 3 halves, and 3. And that way the system would be solved. Okay, so now you know how to do Gaussian steps in order to get a matrix into row echelon form. Thanks for watching.